the definition of hybridization? Mixing of atomic orbitals belonging to the same atom having slightly different energies to produce a set of orbitals having equivalent energies is called hybridization. That means intermixing of atomic orbitals belonging to the same atom. Okay, and in between them there is a slightly different in their energies. By combination of these, they form the hybrid orbitals which are equivalent in their energies are known as your hybridization. Now, hybridization can be categorized into two types. One is the hybridization involving s and p orbitals, and another one is the hybridization involving s, p and d orbitals. First of all, we'll observe what are the characteristics of hybrid orbitals involving s and p orbital. Now, there are three types of hybridization. That is, one is sp, sp2 and sp3. When the hybridization is sp, that means the involving orbitals is one s and one p, and the orientation of this, that is the geometry, is linear shape, which bond angle is 180 degree, and the percentage of S character is 50%. How can you calculate the percentage of S character? Now see here, this is the formula of calculating the percentage of S character. This is equals to number of S orbitals involved in hybridization. That means here the number of S orbital involved in hybridization. How many S orbital involved? 1 S. So this is here, it is 1 divided by total number of orbitals involved in hybridization. Total number of orbitals involved 1 S 1 P means how many total number of orbitals? 2. So 1 by 2 into 100%. So this is equals to 50. So the percentage of S character is 50%. Similarly, when the hybridization is sp2, the orbitals involved is 1s and 2p. p2 matlab 2p. Now what is the orientation of the geometry? That is trigonal planar, and the bond angle is 120 degree. Now here the percentage of S character is the number of S orbital involved is 1 divided by how many total number of orbitals? 1 plus 2 is 3. So 1 by 3 into 100. So it is 33.3%. Okay, third one is sp3 hybridization, where involved orbital is 1s and 3p, and the orientation is tetrahedral, bond angle is 109.5 degree. Okay, and here the percentage of S character is involving S orbital is 1, total number of orbital is 4, so 1 by 4 into 100% is 25%. Okay, now similarly we can see what are the hybridations involving sp and d orbitals. That means what are the orientation and what are the orbitals involved. If the hybridization is sp3d, then the orbitals involved is 1s, 3p and 1d. So all total, how many total hybrid orbitals are formed here? 1 plus 3, 4 plus 1. So total number of hybrid orbitals formed here is 5, and the orientation is diagonal bipyramidal. Similarly, when the hybridization is sp3d2, the number of orbitals involved is 1s plus 3p plus 2d. So here, how many total hybrid orbitals formed? 2, 3 plus 1, 4 plus 2, 6 hybrid orbitals formed, and the orientation of the orbital is, that is geometry, is octahedral. When the hybridization is sp3d3, then the total number of orbitals involved is 1s, 3p and 3d. So all total is your 7 hybrid orbitals formed, and the orientation is pentagonal bipyramidal. Okay, and in this case the bond angle and the shape is different. That means more than 2 types of angles are present in one hybridization. Second period elements do not show these hybridizations as they do not contain d orbitals. Okay, because those elements which contains the d orbitals, they can only show the hybridization involving d orbitals. So these elements cannot have the covalency beyond 4. And the second point is elements which have vacant d orbital, that means the third period onwards, and they can show these hybridization and they can exhibit the covalency beyond 4 by making use of d orbitals.